Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to do a little coding with the TI-84. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. Tonight, we're joined by Becky Beyer and Becky Underwood. Becky Beyer is a nationally board-certified teacher who teaches grades 9 through 12. Her current classes at Kelly Walsh High School include AP Statistics, AP Computer Science Principles, AP Computer Science A, C++, and Python. So it sounds like you have a lot of experience with this, Becky. We're excited to have you with us tonight.
It's great to be here tonight.
And unfortunately, the other Becky Underwood, is not feeling well and so is not going to make it tonight, but has put a lot of work into the webinar with Becky Beyer, and so I didn't want to discount her. I wanted to at least introduce her. Becky is in her 4th year of retirement after teaching high school math and computer science in Casper for 33 years. She has taught everything from foundations mathematics to AP calculus and AP computer science. Becky used the TI-82, 83, 84 calculators for the first 20 years of her teaching career. However, in 2011, she was invited to be part of a teacher leader cadre with Texas Instruments focused on training on the TI-Inspire handheld and the TI-Inspire Navigator, and this really changed her teaching for the better. Becky's been a TCUBE regional instructor since 2012, so again, we're sad that Becky Underwood can't make it tonight. Becky Beyer, would you mind discussing our agenda for tonight?
All right, we're going to start with the TI-Innovator Hub on how to just change the RGB colors on your TI Hub. So we're going to set the colors. We're going to get input from the user so the user can determine how much red, green, and blue they want. And then we're going to put it inside of a loop and use the while not escape so that it will continually ask for new red, green, and blue colors until you hit the clear button. After that, we're going to move on to sound, and we're going to learn how to play with frequencies. We're going to talk about how notes are related to one another and how you can use a loop to play an octave. We're going to do a little bit with formatting your input and output. And then at the end, we're going to talk about how can you do these two simple RGB and sound to make a game for your classroom. With the game, we're going to talk about the skills that we've used, generate some random integers, and then we're going to use some if statements to make some decisions. And then at the end, it looks like we have a webinar drawing tonight.
We do, so make sure you stick around. One lucky winner will be receiving a TI graphing calculator of their choice. We are going to be using the chat window to send general messages. If you have any questions for Becky, please feel free to use the Q&A window on the right side of your screen. And as a reminder, the session is being recorded, which I think might be really important for some people, because that way you can really go at your own pace if you're having maybe trouble following along with Becky. So without further ado, Becky Beyer, let me give you control. And as I'm passing control to Becky and she's going to start sharing her screen, the one thing that I think is going to be helpful for you, and this is something that we haven't typically done in the past, so I want to make sure I call it out, is Becky's going to be using her TI-84 plus CE graphing calculator connected to the Innovator Hub, and most of you should be able to see that. You probably see at the very top of your screen, you see maybe my video, Becky Beyer's video, and then a video of her graphing calculator and Innovator, and so it'd be helpful to have that, just that particular image bigger. So if you can move your mouse and just hover over that other Becky Beyer, the one with the calculator on it, and you'll get those 3 little dots in the top right-hand corner. And if you click those 3 dots, click Move to Stage, and that should change the layout just a little bit right there for you. And if that's not big enough, because right now you probably have those 2 or 3 windows on the left, and then maybe the chat and Q&A on the right. If you just want to see just the 84 large and in charge, you can, in the top right-hand corner, move your mouse up to Layout and click Full Screen View. And that should make that even bigger. It's going to pull the chat off the side. So if you have any questions about that, let me know in the chat window. Other than that, Becky Beyer, it's all yours.
All right, as promised, we are going to start from the ground up. So notice I have just turned on my TI or my TI-84 CE to program in Python. You just press the program key, and then you're going to go down to the Python app. And then if you have some things already inside your Python app, you'll notice I have quite a few things that are already there. They'll list them for you. To get started with a new file, new is right underneath the zoom key. So right here, you're going to have run, edit, new, shell, and manager. Those are all going to be run using the Y equals, the Windows, the zoom key. So I'm going to go ahead and choose new. Because I know that I'm going to be using the hub, it's going to be beneficial for me to hit the types and choose that I am going to be doing a hub project, and I'm going to show you why that's beneficial. So I'm not going to select that for a minute. If you go with just a blank option, and let's just call this program B, and I say okay, you get a completely blank screen. Nothing is already preloaded for you. But if you know you're going to be working with the hub, it's a little more beneficial when you choose new to say, I'm going to do a color file tonight. So make your color file and say types, and then pick 6 for the hub project. Because now when I hit enter, you'll notice it already does 2 library imports for me. One is the TI system import, which is going to bring in the hub features. And one of them is the time library. If you forget to do this at start time and you have a blank screen, you don't have to start over like I did right there. You can actually go to the functions, which is my Y equals. And then from my functions, notice there's a modules off to the right-hand side. So I can use my arrow keys to get over to the modules. And that TI system is number 4. And if you just chose number 1, it would go ahead and add that line. I'm going to go ahead and do that for me. It would add that line to my document. So if you're doing this with students and some of them forget to do those 2 library imports, they can either start over and choose those 2 imported options, or they can go ahead and just do those separately. If I wanted the time one, I can go functions over to the modules, and notice time is there as well. Time is going to let me do stuff like sleep, which we'll use our sleep later on here in our projects, and they would just import it. And then again, if you get too many, you just clear it from your list. Okay, so like I said, we're going to start out with a hub project. The first thing I want to do is talk about built in on your TI hub. If you take a look at a hub, there is a little built-in RGB LED right here that you can turn on and off. Anybody know what RGB stands for? Go ahead and type that in the chat window. Red, blue, and green. You got it. Anybody know what the minimum number is for red, blue, and green? Okay, so there's our max. So we're at 256 and we're at 0. Actually, I think it's 255, but we can try 256. But I think it goes from 0 to 255 is your max. If you type in 0 red, 0 green, 0 blue, it will actually give you kind of like the light will be turned off. Any guesses what 255, 255, 255 is? You got it, Stacy. A 255, 255, 255 will give you a bright white screen. So we are going to do our first project that will let us go ahead and set that color. So the very first thing, we're going to go back to that module menu. If you know the syntax and you want to type everything in, you can, but I find it's easier to go to the menus and go back to that module menu and then go down to the hub. And for right now, everything we're talking about is a built-in. That RGB light is already built into my hub. So I'm going to choose one for a built-in device. And then I'm going to say, I want color. And then that will go ahead and import color for you. And now when you choose function and you go back to the TI hub, wait, I went too far. Let's try that back up for a second. If I go functions and I go just to the module menu, sorry, Notice colors now an option. And if you didn't notice that ahead of time, this was not there until I imported the color option. But now I can go down and choose color and then choose RGB. And then I get to decide how much red, how much blue, how much green I want. So if I wanted to say 0 for red, and then move over and do 0 for green, and then let's go, I like 255 for blue. It's going to be a nice blue light for us. It would run had I actually done that on my hub right here, but I've got my hub connected to my calculator, not to my computer. It would be really simple to just hit the run button, and then it would run it on your hub, and we're going to see that here momentarily, and I'm going to let you guys play around with colors. But that's as easy as it is to turn on a color if you want one preset color. But it would be, I think, a nicer program if you could let the user, not the coder, decide how much red, how much green, and how much blue they wanted. So if you want to add a line, I'm just using my arrow keys. You're going to hit enter, and it will automatically move those down. And we're going to make our very first variables. Python takes 3 types of variables. Anybody know what the 3 types of variables are for Python? At least 3 main ones for input. You got string, int, and float. So by default, input is going to be treated like string. So it's going to be letters A, B, C, D, E, F, G. If you type in a 15, it's going to assume that you were wanting to treat that like a letter and not like a number. So we are going to have to convert it to an int. So to get us started off, I'm going to make a variable. I'm going to call it R. And then I'm going to go to my equals, which is going to be inside my test. So my R is going to come as an input from user. Again, I know the syntax is int input. If I wanted to type that all out, I could, but it's built in. If I hit my functions, notice the type has options for int, float, and string, just like was placed in the chat box a few minutes ago. So I can say int, and then go back to my functions, and go to my input output. And then I'm going to type a nice sentence for the user that says enter the input or enter the number. I could use my alpha keys down here, but it will be easier if you're on computer software, or even my students sometimes thinks it's easier on their calculator, to notice there's this other menu that lets me hit the window that will then give me access to a wide array of characters. And it might be easier for your students to go ahead and use this to type in enter, and then I'm going to put a space. And notice I can still use the keyboard from here. And if I wanted to say a number, so I'm going to go ahead and painfully type that out because I'm sitting at my computer screen, it's not a touch screen. Or I could just use my keyboard and say enter a number, and then close my quotes like so. And then notice the option to paste is at the very end. So I'm going to say paste that in. And now my code says int input enter a number. So I'm going to repeat that process for my blue and for my green. I could type all of that again, but everything is menu driven. Any idea which one of these menus might have something useful that maybe would let me copy and paste? Which one of those titles sounds like it might be a useful copy paste? Tools. Tools is a great idea. Let's go see what's in that tools menu. So tools will do just exactly that. It will let me copy a line. And then I go back to tools and I can say paste the line below. And now I can go to my line and just edit that so that it's going to ask me for my green. I might have been a little more descriptive with my output and said red and then blue and then green. But I wanted to show you guys how useful that is to kind of copy and paste. A few windows open, and I think I just deleted the wrong line. So let's come back one more and hit delete. And then here is going to be my green. And then I can go back to tools and it will let me paste whatever was copied in there last. And so I can go back and I can change this to a blue. Oops. On Lineback. Try that again. Many arrow keys. Oh, I did it again. Delete. There we go. Blue. And let's go add that closing parentheses at the top line. I don't know about your classes, but if you've done this with students before, it's really easy for them to forget if they're typing at their keyboards to put those two closing parentheses, one for input, one for int. So what I really like by using the menus that TI is embedded in there is the kids don't tend to forget those parentheses because it already does it for them. If you wanted to, you could come back in here and you could edit this and say, we could have just said enter a number for green and then went ahead and put our values in there to let them know what they're doing. And then you'd come down and you'd edit your statement and you would say, here's my red, here's my green, so that's an L, there's my green, and then my blue is the last one. And then you could have your students play around with it and run it and try them out individually. If you left your code like it is right now, you would have to run your code, change the light, run the code, change the light, run the code, change the light. So what coding tool might make it useful so I could repeat my action and ask over and over and over again for a new color, and it would repeat asking and displaying that color? What coding concept? You got it, a loop. What's nice, I think this is kind of a cool feature that they've added on the calculators. There is a while loop. That's an even more specific loop. There is a while loop that's built in that says while the user doesn't press the clear button, go ahead and execute your code. And if you forget which module that happens to be in, all you have to do is hit your Y equals, go to your modules and say, okay, I think maybe that sounds like it could be a hub command. And when you look at it and say, oh, hey, it is in the hub, notice it says while not escape. And then off to the right-hand side, it tells the user who's coding that the escape key is really your clear key. So I go ahead and hit enter. And then for those of you who've coded in Python before, notice it automatically indents. I love the fact that it gives me two little diamonds. I don't know about you, but I've spent hours trying to debug students coding because I didn't notice that they had one extra space or one too few spaces somewhere along the way. So that tells you that this first line is indented twice. I'm going to have to indent everything else. So if I go down to the next line, I go back to that tools menu that we had from before, I can indent and then go back to tools and indent, and I can indent or unindent if I go too far using the tools menu, or if you go too far, you can just delete them. And so then I'm going to back up just a little bit. Oops, I deleted my cursor again. Yeah, the insert paste below really does help out a lot. And then I go back to my tools, and then I indent. And then there's one more thing that I like to add to the bottom of my program. Because this one right now is immediately after it changes the color, going to ask for red, green, and blue. It's not always going to pick up when the student hits the clear button. So I kind of added a safety net to my code. And I went in and I used inside the time module this command for sleep that pauses my calculator for only 2 seconds. So if students don't like the color that they did or they're ready to escape, after they've typed it in, they've got 2 seconds and they can kind of hit that clear button before it prompts this next question. Otherwise, they're going to have to wait till they answer the questions before they can hit that clear key. So without further ado, that's what the little screen on the right-hand side is going to show you. We're going to play around with it in action. So if I turn it on and I hit my program button and I go down to Python, and I choose my color program, it automatically pops up the question for me and it's asking me how much red do I want. So do you guys want a lot of red or not a lot of red on this first one? Do you have a vote? Any ideas? A lot so we can see it. Good plan. So how about I type in 200 for red? 200 should give us a lot of red. Okay. Do we want a lot of blue or not a lot of blue? See another lots. I don't know if that was a lots from before. Yeah, in the middle. Okay, let's do in the middle. We'll see a lot of red. And then I'm going to make, oh, I see a lot of blue. How about I go with a lot of green for this one? I hit the enter button and there you go. You guys have a nice bright light. There's 200, 100, and 200. So there's my color. It's now prompting me on my screen for a new one. So I could go back and do somebody's choice where they said, let's do a lot of 200, no blue, and 200 green. And notice now I kind of end up with a nice little yellow color. And so it's kind of a nice activity now to ask your students to play around and come up with different conglomerations of colors. So any idea how to make a teal color? Let's do number theory. What do you guys think if I wanted teal? Give me all three numbers at once. How much red, how much blue, how much green to make teal? All right, let's try that out. Someone said 0, 150, 200. I would go with that as a nice pretty color of teal. Okay, so this is one where kids kind of start having some fun, kind of getting themselves some how much green, how much blue, how much yellow. It's also where some of my students will start Googling and saying, what's the RGB color for this? What's the RGB color for that? So there is going to be step number 1, how to set color. That's the quiet activity to do in your classroom. So now we're going to kick it up a little notch, and I'm going to teach you how to be not so quiet in your classroom with a little bit of sound. So to change, I'm just going to hit my function button, and I'm going to go choose new. And then since this is going to be something from the hub, I'm going to go ahead and choose types and choose hub. That way it already imports my time and my TI system library for me. This one's going to be sound. So I'm going to go ahead and say okay. Tells me sound is unavailable. It's a name that already exists in Python. So okay, we'll change it. Oh, gotta go back. How about sound with 2 Ds? And then I go back to the hub project. And it says, okay, you can do that one. The hub is a device that is connected to your calculator. That is correct. So right now I'm the code that you're seeing on the big screen, that's me using my TI Smart View. Off to the right hand side, the small screen is my little TI Innovator Hub box that is connected to my calculator. Okay, so I have that imported. I want to So notice when I go to the module option, I'm back to my default 7. My color is no longer an option. I haven't imported that yet. Nothing says sound. When I go to the TI Hub and I go to built-in devices and I go to sound, now it's got a line that says import the sound library. So when you go back to your modules, notice I now have a sound option. So to play a sound, it's just one line of code. I like to play with the tone and the frequencies. You can choose note if you know the note's name and how long you want it to play. But for my math classroom, I think it's kind of fun to have the frequency because you can set a numeric value and then how long you want that tone to play. So Josh says that a 440 is an A. That is, I think, true. I think I remember seeing that when I was playing around earlier. 264 is the one I usually start with. Anybody know what 264 goes with? It is middle C. So 264 is middle C. And that's where I start with my students. And you can have them play it for 2 seconds, or you can have them play it for 3 seconds. Anybody know the relationship from one note to the next note? How are they mathematically related to one another? Oh, good, we're gonna do a little math tonight. Okay, so to go from one note to the next note, they're actually related by the 12th root of 2. So a fun project to do with your students is to take middle C, and you can say, let's multiply it by the 12th root of 2. I like dealing with exponents more than I like dealing with roots. And so I would tell my students to raise it to the 1/12th power, which is going to bring us to an interesting fact about Python. Watch what happens when I hit the caret key. In Python, the caret key, the exponent, is actually a times times. So anytime you want an exponent key, when you hit this little caret key, you're going to get a times times. If you actually use the caret symbol, which you can get by going through the catalog, it's going to do some bitwise operations for you. So I could say I want to have middle C by itself. So I could go, let's just go to the, anything to the 0 power gives me back the original. So I would have 264 times 1, which would give me middle C. Or I could come in and I could change this to a 1, and now I would have 264 times 2, which would be the note right next to middle C. And then if I changed it to a 2, it would give me notes 2 next to middle C, like so. So you could have kids kind of play around with the sounds by using that feature we just did with the color. You could create a variable. And so I'm going to just say n for number. And I can go back to that test and get my equal sign. And then just like what we did with our colors for our RGB colors, you're going to go back to the types, and you're going to get an integer. And then you're going to go back to input output, and you're going to ask for input. And then again, I like to use the shortcut key, the window button that opens up that A command, because then inside quotes, I can say, enter a number. And I mean, I guess I made mine an integer. If you wanted to, you can make it a float and see how that changes if you don't have a whole number in there. The frequencies will still play. And so then I paste it. And now for the code, you could just change your 2 to an N. And then I could play my different notes. So without further ado, let's watch this in action. If I go back to my handheld here that's hooked up to my Innovator, I'm going to go ahead and unplug it for a second so that light stops shining. Oh, it's not going to stop shining, so I send a new project. Okay, there it goes. So I'm going to go hit my Files button on my calculator to go back, scroll through. I had already pre-installed this music file that we just typed together. So I'm going to enter a number. So I'm going to type in 0, and you guys tell me if you think this sounds like middle C. All right, was that loud enough? Did everybody hear it, or do I need to move my hub closer? No? All right, let's try moving the hub a little closer. You hear it that time? Oh. Okay, so unfortunately my mic is not picking this up, so I anticipated having that maybe be an issue, so I made a video of that happening. So here's my one video. I cannot sing. You guys do not want to hear me sing. Thank you for asking, but singing is not my forte. So okay, did the sound come through on your guys' end when I played the video? Or did you guys have a silent video? Okay, so I apologize for that. You guys are gonna have to take my word for it. Honest, I've got music going on over here. I've got a dog looking at me in the background going, what are you doing? So there is sound. Obviously my machine just is not picking up the tone for it. But it definitely gives you your sound. And if you do this with a room full of students, you know they're not going to be in sync. You're going to have sound going all over the place. But the sound does come right out of the hub. And it did go nice and straight through there. So sorry about that. But you guys can, if you have your own hub, you can go code that and listen to it all you want. Okay. So we're going to move on a little bit. So from there, I guess we will do it soundless. You can actually play an octave on your calculator and have it go through all 8 notes on an octave, all 12 notes on an octave, sorry. Yes, the whole scale. Thank you. Any idea how I'm going to make it play a note and then go to the next note and then go to the next note and go to the next note, the whole scale, and get to the next octave? There's my math term. Stacy thinks it's a good time for a loop. Somebody else, Josh, thinks I should go from 1 to 12. Perfect. So as you saw in the last one, it's really easy to run through a loop. You're going to, if I'm going to get rid of the student input, just delete that. Instead of doing the while escape key, I'm just going to use a for loop. So I'm going to go to my function and I'm going to go to control. And then I'm going to say for I in range. And then if I want the whole scale, it's going to go from 1 to 12. So you are correct. And then all I have to do is indent this one level, which was inside the tools key. So indent. And then my N is already there. There's one last thing I need to add. Anybody have an idea what the one last line of code after playing the sound I might need to add before it loops back up? You got it. I need to add a sleep command. Otherwise, it's going to go through all of my commands and not actually let me hear them because it's going to, the processor is going to go faster than the hub can to keep up with it. So last but not least for my code, I would go to my time option and I would say sleep and then I would put a 2. And then somebody, thank you for catching that one. I did say for I in range and I have an N over 12. So let's go ahead and change that to an N. And then if we had sound tonight and I could plug this in, you guys would hear the whole scale starting from middle C and go all the way to the next octave. Can I make it run up, then back down? Yes, you can definitely make it run back up and run back down. Any ideas how you could make it run down an octave after it's gone up? Well, if I made it count from 0 to 1 to 2 to 3 to 4, to get it to go back down an octave, I just need to count down. So my code for this guy would run up The nice part is we already have it typed in there. So I would do a different loop. I'm going to go to Tools, and I'm going to say copy this line. And I'm going to go to Tools, and I'm going to say paste this line. And then here's where you're going to really want to pay attention, because right now this for loop is inside my for loop, which would make it run once, and then it would run this for loop on the inside. So if you want it to do your first for loop and then the second for loop, you need to unindent. So I could either use that tools option for unindenting, which I always forget for some reason unindent is there, but to me I go there to indent, or you can just delete them. And then to count down, you're going to say 12, and then you can add a comma and a 0 and a comma and tell it to count down by a -1. If you just say 12 to 0, the default is to count up. And so you can't count up from 12 to 0, so your loop actually doesn't execute. So you do need that third parameter to tell it to go ahead and count down. Yep. And then I'm going to come in here and I'm going to copy my line. And then I'm going to paste my line. And then I would copy my sleep line. And then I would paste my sleep line right below. And then when I ran it, it would go up an octave and then it would go down an octave. There's a couple of interesting things about loops. If you haven't played with loops much on Python, let me make us a new one just to kind of show you. This was this nice, clear, empty guy. For a for loop, you have 3 options in Python. So the first option is a for I in range. So if I say for I in range of, let's just go to 4, and then I tell it to print. Print is going to be my input output. So if I tell it to print my I value, your I is going to go from 0 to 4, but watch what happens. When it gets to 4, it doesn't continue with the loop. It stops executing the loop, and it just stops. So when you use the for in range, it will make the loop happen however many times you put in there, but you need to realize that your counter variable, my I, what I'm incrementing by, is going to start at 0, and when it hits the 4, it stops. The other form of an if statement, there's 2 of them, or 3 of them, like I said, is the for I in range. And this one you get to pick where to start and where to stop. But again, notice I start at 3, I stop at 7. So when I tell it to run, I get 3, 4, 5, 6. I don't actually get the counter, that I value, to be a 7. It checks it, it realizes it's a 7, and it doesn't execute my loop. And then that last parameter down here will let you change your step size. So if I wanted to do something crazy and count from 3 to 70, counting by 2s, again, once it gets to 70, it'll stop. But now it will print counting by 2s and stop at 70. The one thing my students do have a problem with is going just in reverse. And they will try to say, I want to go from 30 to 7, counting by 2s. And then when they run it, they're expecting it to go from 7 to 30, but it doesn't work that way. It realizes that the first number is larger than the second number, so you actually have to put a negative sign in there for your step size so that it will actually count down for you. So just kind of a little, I guess, side note about running loops and how those loops work in Python. Okay. So last but not least, I'm going to walk you through a game that's not going to have any sound, which is interesting. but we're going to combine a light with a sound to make a game for your math classroom. So I want you to think about the number sense that students might need to have for Algebra 1 or Algebra 2. A lot of times my students might need a little extra practice with their math facts, whether it's adding numbers or multiplying numbers. And that's a little boring, but it's very useful for, say, something like factoring. So if you can turn it into a game, kids get a little bit more into it. So what I made was this game that's going to let us practice finding numbers that multiply to one number and add to another number, so that if you wanted to practice some number sense before you did factoring, or even while you're doing factoring, it would give kids a little bit different ways to practice that. So it will be soundless, but I'm going to go ahead and use the video. That way it's a little bit larger for you to see. And then I'll show you what the code looks like. So to begin with, sorry, it's sideways, but I thought we were going to get to see both this and hear some sound. So to begin with, when I run the file, notice it's going to ask me, I need two numbers that add to a -1, and they need to multiply to a -56. So I'm going to type in a -8 and a -7. And then what you can't hear, because my computer's not picking up the sound, is that was incorrect. So the tone I set for incorrect values is really low. And it tells me I'm wrong, and it tells me what the right numbers were. So I had an extra negative sign in there. It's keeping score for me. And this time I got it right. It says correct, and the sound is higher. And now if I type it again and I do another correct one, I have a nice high sound tone. So as the students are playing the game, they get reinforced with the different tones they set for correct and incorrect. Gives them a little bit of instant feedback. It's fun to have in your classroom, having 82 different versions of it going, but the kids get excited. And then at the end, it has different colors that display. So if you wanted to take your grade, or you wanted to just kind of spot check to see how kids are going, I made this one only happen 5 times. And if they got all 5 right, it was magenta. If they got 3 or 4 right, it was yellow. And if they got 2 or less, it was going to be a blue color on the hub. So ideally it would be nice if everybody had their own. I don't have that many hubs in my classroom. My kids share, so I have one hub per set of 2 students. And so I've had my kids share back and forth with the hubs when they do stuff like that. And again, I like that, yeah, the sound frequencies are great because it's some instantaneous feedback. The kids get to pick their own frequencies, and I let them sometimes play around with picking their own functions. So without further ado, I'm going to walk you through the code first, just because I'm looking at the time that we have left. And then I'm going to show you how to get some of the key parts for the code. So if you have any questions, feel free to throw them in the chat as we're going over the code here. So I called my game the product and the addition game. And so when we go to edit it, you'll notice that I have the TI system import and the time import. Those two were imported when I started the hub. And for those of you who are going to try to frantically write this down, there's a handout at the end, and we'll talk about how to get that has all of the code in there, so you don't have to try to write all this down. I've got it all detailed for you. The next thing is a new library. We have to import the random library to get random imports or random numbers. So to import the random library, it's just that function. You go back to modules and you go to random, and right there you're going to say from random import, and that's what's going to allow me to generate random integers for my students. And then you have the 2 imports that we had, one for sound and one for color, which is what we used earlier tonight. And then I made myself a total variable so that I could keep track of how many students had right and how many students had wrong. I set this up to only have 5 questions because I was making it short for you guys tonight so you could see what was going on. You could have students set this at 10, you could have them set it at 20. Really, you make the decision where you want those breaking points to be. Then I have 2 variables. Notice they are both indented 2 spaces because everything here is going to be inside my loop. And so that was the default indent spacing, which is nice and easy for you to see as a teacher. Number 1's a random integer from -10 to 10. If you want your students to practice smaller numbers, they could do -5 to 5. If you want them to know through 12s, you could change your 12s there. I went ahead and stored the product and the sum as 2 different variables. It just made it easier for some of the checks that we're going to look at here later on. So I went ahead and I printed the sum and printed the product as you saw on the screen. You cannot generate a random integer unless you import the random library. That's correct. And here's what I tell students. Every time I import a library, it's like I checked out another library book. It's making my program a little bit bulkier. And so if you're not going to generate random numbers, it's nicer to make your program lighter weight so it takes up less space on your calculator. Not that importing the random library is going to add a whole lot of weight, but over and over it would add some weight to your projects and take up some memory. Okay, so A and B, just like we did with our other inputs, they're integers because that's what you generated. Then I have an if statement. We didn't use if statements in our other projects tonight, but if you saw them, you might recall they were in with my for in range. They're in the controls. By default, it will give you an if else, or an if else. Those of you who've coded before, this might be a little weird. It's weird for me to say. It's not else if, they're not separate, but it's elif, all one word. And if you want to have more than just one case, you could do if, elif, else, and that would give you 4 cases. So you just keep adding more elifs in between for the more cases that you have. So if my 2 numbers that I typed in match the sum of the random numbers, and my 2 numbers multiplied together gave me the correct product, I would go ahead and print correct. And then I picked a tone that was a little bit higher than middle C. Again, I would let students pick their own tone, or you can set the tone, it's up to you. I only played it for 2 seconds. And then this is shorthand for Python. You can say T equals T plus 1, or just T plus equals 1 is kind of the shorthand and it will add it to it. I'm adding 1 to it so that they know that they got that 1 correct. Good question, equals. So 1 equals by itself means assign it a value. So it says input this information and assign it or give it to the variable A, so it stores. Assign or store this value in B. Equals is a comparison. So you want to check to see, are these 2 equivalent? You don't necessarily want to store one in the other. It does matter what order you assign variables. So the variable has to go on the left that you're assigning to, and the value that you're storing in that variable is on the right-hand side. Okay, so then, oops, I'm going to continue down below. I'm going to go to my else statements. So it's fairly similar, only instead of saying correct, I said sorry. And then I used commas. The commas are kind of nice because I can concatenate or join string and variables together without having to do any sort of conversions. It will just add a space in between those. If you want to know how to concatenate without adding space, we're going to talk about 10 minutes of code here in a second, but they can show you a different way to go ahead and print values. And then notice this is a lower tone, and had the video picked up on my computer, you would have heard the 2. And then I do have it sleep for 3 seconds so the kids can hear their tone, they can look at the answer before they loop back up. For my students, I might even actually have this pause for 5 to 10 seconds just so they're thinking about what they missed if they missed something. Then I printed a space, and then I printed their score just so it was easier. Any idea why their score is an I+1 and not just printing I? If I scroll back up and see that I is the counter for my loop. What's the starting value for I? Anybody remember in a loop? It starts at 0. Yep, starts at 0. So the first time through after you've answered one question, if you get it correct, it's going to say 1 out of 0 because that's the first time through the loop if you don't add 1 to your answer. But you can go ahead and add it right there. You don't have to store and create a new variable. If you wanted to, you could come up in between here and create yourself a new variable. Of course, I went ahead and grabbed that extra thing. Okay, I can come in here, create a new variable, and just say it's my total. It equals I+1 and put it there if you don't like the way that looks. And then at the very end, after they've answered all 5 questions, here's where I've done an if statement outside of my loop. So if you'll notice, everything that's inside my loop is indented 2 spaces. The ifs indent an additional space to keep them together. My else is indented an additional 2 spaces to keep them together. After the kids have answered all 5 questions, or however many you want them to place, then I go ahead and I change my color. I liked magenta, so I made magenta the correct color if they got everything correct. And then it played a nice high sound, and then I had it go a little bit higher, and then it dropped back down just to kind of add some musical notes. Your kids will go crazy and compose all sorts of things for their correct answers. And then I said, okay, well, if they didn't have it perfect, but if they got 3 or 4 correct, it was teal. I think that's teal. And then I just played a different sound. So again, they could hear that different sound playing. And then if they got less than 3 correct, here's a new color, and then a new little type of song that could play when they're done. And then they could just repeat their code. So that's one way if you wanted to incorporate everything that we just did with colors and sound and into a game. You could have a nice game to play with either Algebra 1 or Algebra 2, or make it your own. Take some of your content that you're teaching that's a little bit different, instead of have it being 2 numbers that kids type in and then add to it. There's a lot of other games you could make that are fairly similar, kind of the same idea. Is there a way to connect a hub to your SmartView emulator to discuss demonstrations? I do not believe so. That's why I have my hub connected to my calculator. But it was really easy. I took the code for tonight and I just downloaded it to my calculator, which also makes it easier for me to go back and forth if I'm presenting, to go ahead and run one, but leave the code up there for the kids who are still trying to type the code in. Another thing that's nice, though, if you're going to download this to a calculator, if you've not done that before, when you go to, oops, let's quit Python. Yes, I'm okay with quitting Python. When you go to save any of these files to your desktop, so let's say I'm going to take this color app that I just made and I'm going to save it to my desktop, you actually have the choice to save it as either an app variable for your Python for your calculator, or you can actually save it just in plain Python. And then you can open that up in any sort of editor you want. You can open that up in just a plain Jane Notepad text editor. Or you could open it up if you're running some other IDE, you could do that there as well. And actually, if you know all of the commands that you're typing and you'd rather do that than typing on your calculator to begin with and then demo to your kids, you could type it in Notepad and then import a Python file. So any Python file you have, you could import and then just adjust it a little bit if you need to. So that's kind of a nice little tool. Another thing that I have found that's really handy is how to make a copy that you want to then enhance. So you want kids to maybe have version A, but then you want to modify it to make version B. When you're inside the Python editor, you'll notice I have a lot of files in here. As I scroll through, I've got a couple different versions of quadratic formula that I've done with kids. So maybe my Algebra 1 students, they're going to have the quadratic formula that only does integer values to begin with, and then I want them to be able to do rationals, and then maybe I want them to also have imaginary numbers in there. You can take any project that you code and make a copy of it that then you can edit and save under a new name by using this manage tool. So if you hit on the graph, you can replicate a program. So I was next to the CL program, so I just give it a new name. So let's say this is my clear program instead of my CLR, but I think I already have a clear. Then when you say okay, it imports all of the code that you had from before. And now if you edit and change it, You have the original CL on your handheld or on your computer. It works both the same way. But then you also have the new version as well, which I think is really kind of nice, especially when you want multiple versions where they're just taking it a little bit further. All right, with that, I am looking at the time, so I'm going to turn it back over. I can find my turn back over button. So I'm going to stop sharing. I think I passed that back, right? Okay.
Yep. Thanks so much, Becky. Let me actually steal it. So hopefully there was some learning that occurred today, and if there was, do me a favor and reach out on any of the social media outlets and share what you've learned or continue some of the conversations that we had tonight. They were really great. If you have any last-minute questions for Becky, please do your best to try to get those asked. I know she will do her best to try and get them answered. To receive a certificate of attendance, let me go ahead and put this in the chat window. Also listed is a link for the documents tonight, which I know Becky had referenced and spent a lot of time on, so please check those out. And if you're missing these links for any reason, hang tight. You'll automatically get up a follow-up email in a couple days, and that follow-up email contain links to the recording, which is helpful, the documents, and the certificate. And if you're watching this on demand, go and copy that link into your favorite browser to receive your certificate. I think we forgot to do our webinar drawing. So one lucky winner tonight, as mentioned, is going to be receiving a TI graphing calculator of their choice. And tonight's lucky winner is Sharon Cade. So Sharon, congratulations. We'll be in touch over email in the next couple of days to give you some more information about that. And when you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, so we really hope you share those thoughts. Big thanks to both Beckys. Unfortunately, again, Becky Underwood was not able to be with us tonight, but Becky Byer, thanks for carrying the torch and spending so much time with us and helping us with some of our coding woes. So thanks so much for putting all this together.
I hope you guys had as much fun as I did.
No doubt. And thanks everyone for joining us. We hope to see you back online real soon. Have a great night.